perpendicular lines. Just a reminder, general equation for a straight line, y equals mx plus c, where m is the gradient, that's just a measure of steepness of that straight line, and c is the y-intercept, where the straight line cuts through the y-axis. To get the gradient, then we just need 2 points, x1, y1, and x2, y2. And then to work out the gradient, we just throw in those values into this rule here, which is basically just rise over run. To get the c value, then after we've got the gradient, we can just simply sub in a known point that lies on that line to establish what the unknown c is, or we can just observe where that line cuts through the y-axis. Parallel lines will have the same gradient. Perpendicular lines meet at right angles, and when you multiply their gradients together, the result will be -1. So you can use this fact here to go backwards and work out what a perpendicular gradient is when given a certain gradient. Let's look at an application of this. So here in problem 1, find the equation of the line having a gradient of 3/4 that passes through the point 7, 11. We need to express our answer in two different formats. So the traditional y equals mx plus c, but also the format ax plus by plus c equaling 0. So we'll deal with b first of all. So the gradient is 3/4. The equation of a straight line, y equals mx plus c. I've got m equaling 3/4, but as you can see here, I don't know what c is. I'm now going to sub the point 7, 11 into this equation, and that will allow me to work out what c is. So you can see I've just made y equal 11 and x equaling 7. Multiply those through, and now I subtract 21 on 4 from both sides. Of course, 11 can be rewritten as 44 on 4, so 44 on 4 minus 21 on 4 gives me 33 on 4. So to write down and provide the answer, it's y equals 3/4 x plus 33 on 4. For part A, then I'm required to have no fractions and have everything over on the left-hand side. So I'll begin with the format y equals mx plus c. In my next move, I multiply everything by 4, and that gets rid of the fractions. I now subtract 3x from both sides. Then I subtract 33 from both sides. And finally, I need to put it in the format ax plus by plus c. So I do that there. And of course, that's equal to 0. What I can actually do next is multiply everything by -1. So -3x times -1 is 3x. Positive 4y becomes -4y, and -33 becomes 33, and 0 just still remains 0. Problem 2, find the equation of a straight line containing the points 2, -5 and -3, 1. Express your answer in. Again, guys, we've got y equals mx plus c. We'll deal with that first, and then that second representation. So firstly, let's work out what the gradient is. So it's y2 take y1 over x2 take x1. I'm seeing this point here as being x1, y1, and this point as being x2, y2. So it becomes y2, which is 1, take away -5, over -3, take away 2. And that's what I have here. Of course, this is a double negative, and I end up with -6/5 for m. Now, it's y equals mx plus c. I put in my found gradient, and in my next move, I'm going to sub in a point that I know is on that line. So I can use either one of these points, but I decide to use -3, 1. So x is equal to -3, y equaling 1, and then I can establish what c is, and you can see I end up with -13 on 5, and now I write it down in that format, y equals -6/5 x, take away 13 on 5. So that becomes my starting point for part A. Of course, I multiply everything by 5, and then I add x to both sides, add 13 to both sides, and now rewrite it so that I list my x first. So I've got 6x plus 5y plus 13. Here we have problem 3. Find the equation of the line passing through this point that makes an angle of 45 degrees with the positive x-axis. So if you can imagine, that we've got the x-axis just running through like so. What I want to occur is a line that goes up to the right through it, which will create a 45-degree angle in here. So from the previous work we've done this year, m, the gradient, is equal to tan theta. Theta has been set for us as being 45 degrees. If we evaluate what tan of 45 degrees, we'll get 1. So I know that my gradient is 1. And now it's just a matter of y equals mx plus c. I sub in the gradient being 1, so we now have y equals x plus c. I sub in the known point, so when x is equal to 3, y is equal to negative 3, so I've got y equaling negative 3, x equaling 3, to produce that c, the y-intercept, is going to be negative 6. So the equation on my line is y equals x take away 6. Problem 4. Find the equation of the line that is perpendicular to the line with the equation y equals 3x plus 1 and passes through the point 4, 5. So this is going to be based on the fact that perpendicular gradients, when multiplied together, give a result of negative 1. So I know that my gradient for this equation here is 3, and so I can produce that a gradient which is perpendicular to that is negative 1/3. And you can use this rule here, or just appreciate that it's always going to be the negative reciprocal. So turn whatever that gradient is upside down. So we can think of this as being 3 on 1. So if you flip that upside down, we're going to get 1/3, and then change the sign to get negative 1/3. All right, so the equation is going to be in this format. Y equals negative 1/3 of x plus c. I now sub in the known points. So when x is equal to 4, y is equal to 5. And I can establish, you can see the workings here quite simply, that c ends up being 19 on 3. So I write down the equation here. So what I've just worked out is that a line which meets at right angles with this line, that is that it's perpendicular, but also passes through the point 4, 5, is this equation. B, we need to find an equation that is parallel with this equation and passes through the point 4, negative 7. So with parallel lines, they have the same gradient. So my gradient is going to be 2/5, and that's my starting point. Y equals 2/5 of x plus c. I'm now going to sub in the point x equaling 4, y equaling negative 7. So x is 4, y is negative 7. Multiplying this through becomes 8/5. I subtract 8/5 from both sides. Negative 7 can be written as negative 35 on 5. Now taking away 8 on 5 to give me negative 43 on 5. And finally, we've got y equals 2/5 of x take away 43 on 5. Problem 5. Find the equation of the line which passes through the point of intersection of the lines whose equations are this and this. Given that the required line is parallel to this line, you can use your calculator. So point of intersection. So all I need to do here, guys, is go menu, algebra solve, put in the two equations, and solve for x and y, and you'll see that the point of intersection is 1, negative 4. I now want to work out the gradient because it's going to be parallel with this line, but I can't tell what the gradient is when it's in that format. So I'm going to start with that format and then manipulate it so it's in the format y equals mx plus c. I do that, and you can see that the gradient is negative 5 on 2. So if it's parallel with that, then it's going to have a gradient of negative 5 on 2 itself. So here's the equation of the line that I know so far with the found gradient. I'm now going to sub in the point of intersection to it. So that is x equaling 1, y equaling negative 4. And I can establish that c is equal to negative 3 on 2. So I have y equals negative 5 on 2, x take away 3 on 2. Problem 6. A line passes through these points where a is unknown. Find the value of a. So with this, each one of those points fits on the line. So I'm going to first of all start off by trying to work out what the equation of the line is, and then I can go backwards and work out what a is. So I've got two known points, so I'm thinking this is point 1, point 2, so I can calculate the gradient and get 1/6. And now I've got y equals 1/6 of x plus the unknown c. So I'm going to now sub in a point which I know lies on the line, and that point is 4, -3. So if x is equal to 4, y equaling -3, and I can produce that c is equal to -11 on 3. Now I know the equation of the line that passes through all these points. So y equals -1/6x, take away 11 on 3. Finally, I'm going to put in this third point and work out what a is. So here's the equation. Now let's make x equal to a and y equal to 12. So I've got y equaling 12 and x equaling a. Tidying things up, I end up with -1/6 of a, and I add 11/3 to both sides. And I get 47 on 3 equaling -1/6 of a. And of course, in my next move, what I need to do is multiply both sides by -6. So that will become just a then. So I've multiplied both sides by -6. And over here, I've just written the a by itself to get that a is equal to -94.